Question number 11. The management of a large hardware store is interested in estimating the difference between the mean dollar amount of purchases made by customers who use the store's credit card and the mean dollar amount of purchases made by customers who use a different credit card. A random sample of 74 customers who used the store's credit card showed a mean purchase of $107 with a standard deviation of $12. A separate random sample of 58 customers who used a different credit card showed a mean purchase of $132 with a standard deviation of $9. Technology was used to calculate that the correct number of degrees of freedom was 129.78. Which of the following represents the margin of error for a 98% confidence interval to estimate the difference in the mean purchase amount for the two types of credit cards? So there's a couple ways to kind of think about this. Um, I'm not going to pull the formula sheet out for this one again, but the general formula for confidence interval statistic, in this case, the sample means. So the difference in your two means plus or minus your critical value. So for means, it's T star times your margin of error, or your standard error formula rather, and that's going to be your standard deviation squared divided by its sample size. So S1 squared over N1 plus the other standard deviation squared divided by its sample size. And again, you can find those standard error formulas on the formula sheet. So obviously this number right here is what we're looking at. That's going to be your margin of error. And that's really what we're focused on. So let's talk about first just kind of, again, the structure of how everything's set up. We have a standard deviation of 12. So that's one of the standard deviations with a sample size of 58. Oh, excuse me. A random sample of 74 customers, so that's going to be N1, who use the store's current credit card with a mean purchase, so that's X bar 1, and a standard deviation of 12. And then a separate sample, so independent 2 sample, that's going to be N2, who used a different credit card, showed the mean purchase, so that's going to be X bar 2, with a standard deviation of 9, so that's going to be S2. So really, these are the numbers that are going to go in this square root. So you can see it's going to be like um, 12 squared over 58, or 12 squared over 74. And then the other one's going to be 9 squared over 58. And those get put under the square root. So we'll eliminate the ones that don't have that in there in the first place. And so we can cross that one out, right? And also, if you look carefully, this one's kind of got this big line there. That's not the same as that. Okay, so that's no good. And so now we really can kind of limit it down to these three. And notice they all have different T stars. So we'll just kind of use what we know about getting the T star to help us finalize our answer. So as far as getting the T star goes, if in this case here we're given the degrees of freedom, easiest way to do that is just to use your inverse T. So to use your inverse T, you're going to go to second vars, option 4. And then your area has to be the average of your confidence level in 1. So you have to do like 1 plus 0.98 divided by 2, or you can just think, hey, what's halfway between 98% and 100%, and just put 0.99. But you always have to kind of do the tail ends. So 1 plus 0.98 divided by 2, that'll get you the correct area. And then the degree of freedom, we're provided that, so we're going to key that in exactly as we see it. So 129.78. And that'll give you your critical value that we're looking for here. So it's 2.355424. And so you can see your answer is going to be this one right here, 2.355. And there's other ways to get a degree of freedom here that are going to be more conservative or less precise. So if you're looking at the conservative approach, well, let me go back to the calculator first. If you're looking at the conservative approach, you would take your smallest sample size. So since your smallest sample size is 58, that would be the same thing, but your degrees of freedom instead of this more precise number would just be 57. And that's where you can see where that 2.393 comes from, which is this one over here, 2.394, if you round it to 3 decimal places. If you're using the table, you're not going to get that number. Let me clear all this out for a moment. So on the table, if you're looking at 98% confidence level, and you scroll out to your degrees of freedom, and you notice that you really don't have 129 to work with, so you'd have to kind of bump it down to 100. So at 98%, if you're using your 100 as your degrees of freedom, 2.364 will get you pretty close, but as you can see, it's not quite the same. 364, it would be closest to this, so you could luck out and get that answer. If you use the conservative degree of freedom with the table, it's going to be a little bit different. So you'd have to take 57, but we don't have 57, so we go down to 40, and you can see that would give you 2.423. So that'd just be a higher T star, a little bit wider interval. But because we're specifically given our calculator degree of freedom, we have to go with that. And so we're going to use that 2.355. Again, inverse T, average your confidence level with 1 to get that.